Is my screen visible to all of you? Okay, so I will just start with my screen. Okay, just have a look into it. So we are looking for the second unit now. Previously, whatever was done on the first unit, the videos of the same has been uploaded into this one, the YouTube, and the link of the same is shared in the Google Classroom, where you are all a part of, right? And I want you to go through these videos which has been uploaded into the YouTube channel, right? And also make essential presentation notes out of it. All the related materials with respect to the unit 1 has already been uploaded into Google Classroom. Okay, so now what we are trying to do is start up with the unit 2 of the MBD course. Okay, so till the first unit, whatever that we have so far covered, it is the industrial applications. It is the industrial applications of MBD, industrial applications of Hadoop, right? And it is the industrial applications of Hadoop. Just a second. Hello. Okay, so we are starting with unit 2 now. The unit 2 is on NoSQL databases, right? So we have priorly seen in the first semester that we have covered up something related to relational database management system, parallel databases, distributed databases, and things like that. Now we are looking at not only SQL systems, right? So the not only SQL systems are one of the very important systems of today's era, right? We are looking at NoSQL systems for all the advanced applications, say it be any kind of app today makes use of NoSQL kind of a database. Okay, example of Cassandra being used in Savan app and other Netflix apps and so on, right? So NoSQL databases have taken a very important leap in the industry today, right? So why NoSQL is so important? That is the reason why we are looking at this particular presentation today, right? So NoSQL, first of all, why cloud data stores are important? It is because of the explosion of social media sites. We have got too many Facebook, too many Twitters, too many data handles that are coming into it. Explosion of storage needs in the large websites such as Google and Yahoo, right? Today, when you switch on your Facebook and keep it there for another 2 hours or 3 hours, the amount of data that Facebook collects is somewhere around 2 to 3 petabytes of data. So the rise in cloud-based solutions are very important. Today, nobody is using an on-premise solution. Everybody is using solutions which are with respect to cloud, right? Nobody would like to invest anything on an on-premise hardware storage systems where you locally store the data and manage it and things like that. Nobody would like to do that. So things are shiftly moving towards a dynamic type data models rather than a static type data models, which we have very pertinently seen in case of relational database management systems, right? So these are some of the important motives of why we have to look at the why we have to look at sorry. Okay, why we have to look at the relational data, NoSQL kind of database, right? Now we have also seen Twitter over its capacity, right? There are so many tweets which keeps happening every now and then, right? So this is a very important case study today, right? There are so many Twitter handles that comes in, and there is a lot of amount of data that is collected with respect to that. Now, typical RDBMS implementations, they are fixed table schema. Once when you design a table that you cannot change the table after its implementation. Small but frequent reads and writes, large amount of batch transactions happens, right? Most of the RDBMS systems follow ACID properties, that is atomicity, consistency, isolation, and durability, right? These are properties which we have studied in the first semester as well, right? Now we have also seen parallel and distributed database and data stores which are widely used for meeting the demands of web-based applications, right? Scalability of these application servers is easy, in case of parallel, right? The approach one is you increase the scalability by providing extra database access, by giving extra caching mechanism. But the problem with scalability is there is limited scalability. Using the existing parallel database, expensive. Most parallel databases are designed for OLTP, not for OLAP purposes as well. Build parallel stores with the database underneath. This is another approach, but most of these approaches does not suit our applications of whatever that we are trying to do with respect to the modern days applications. So scaling RDBMS very difficult. The reason is because almost all the RDBMS are CAP compliant. That is, they only enforce consistency and availability. They do not enforce partition tolerance. That is, the database can reside on a single machine and it cannot be split it into multiple machines. The database cannot sit in multiple machines. It's not partition tolerant. So there was a concept called as sharding which was developed, where the data is divided amongst the multiple MySQL database which sits in different systems. But the important issue which came up is the massive amount of reads which happened and massive amount of writes which happened. Parallel access was very difficult to handle. Transparent, not so transparent application needs to be partition aware in this particular case. So hence this partitioning of RDBMS concept first of all did not work properly. So what was the step to move from, let's say that your application is in a relational database model and you need to move to a parallel database model or a NoSQL model. What are the steps in converting that? First is you have a relational database, right? Second is you partition the tables into P1, P2, and P3, right? Certain tables which are residing in the P1 region, certain tables which are residing in P2, and certain tables which are residing in P3. You partition the tables first. Second is you partition the database into three different databases, right? Where the partitions P1 sits here, P2 sits here, and P3 sits here, and the customer is able to parallelly do an access with P1, P2, and P3. The last step is you move this entire database which was locally residing on your machine onto an SQL Azure or a cloud-based platform where there is data federation, liberation of data, and you are able to manage the data on a cloud basis for access by all the customers. So how do we get here, right? If we are trying to do this particular case study, first thing is expensives, because we are using processor, disk space, memory, operating system, softwares, programmers, and so on. The monoculture is limit CPU cycles, disk space, memory, OS, softwares, programmers are monolingual, mono persistent case studies. This is going to reduce the cost of whatever is the implementation that you are trying to do with database. So there was another system which came into picture, which was called as parallel key value data store. Here the key value is distributed amongst various other nodes, and the key value pairs are stored, right? For example, your student ID is a key, and the value that is associated is the student name, right? Likewise, a system came which was massively parallel system. Examples of this was Google Bigtable, Yahoo Sharpa, PNUTS, Amazon's Dynamo, where there were partitioning, high availability, and completely transparent. Sharding was possible with respect to this, but did not support certain relational features like join operations. Right? Very important key thing that you have to remember is, when your database is split or partitioned across multiple servers or multiple systems, join is one relational algebra command which does not work when the database is partitioned. Right? The second important thing is the referential integrity constraint, which is your foreign key constraint, does not work when the database is partitioned across multiple systems. So why was NoSQL originated? Right? NoSQL project originated in 1998, where a low, lightweight, open source relational database was developed by Carlos Strozzi. In 2009, it became very popular, and we had started with a lot of open source distributed databases. Atlanta 2009 conference, one of the NoSQL was released in this particular conference. It was a conference of not so relational database systems. So now first, what is NoSQL? NoSQL basically stands for not only SQL. It's a class of data storage system which is truly non-relational, right? It does not need a fixed table schema, nor it uses the concept of joins to do it. It is purely a distributed data storage system. NoSQL offers more properties than ACID, but it does not come in line with the ACID properties. Hence, we have another theorem called as CAP theorem. The CAP theorem basically stands for consistency, availability, and partition tolerance. So typically, NoSQL APIs, the basic APIs are get key, put key value. These are something related to insert SQL query, delete a particular key, execute a key operation with certain parameters. These are some of the basic APIs which are provided with NoSQL. This is a very, very important slide, right? What are the data models which are available in database systems, right? The first and the foremost is a relational model, which we have already been seeing for a very long time. Second model, the next four models, what you see here, are document, key value, graph, column family base. Now, these four types are actually a NoSQL type of databases. This one is a non-NoSQL type of database where it strictly conforms to SQL type of modeling. Please remember that when you are asked about NoSQL data models, it is document, key value, graph, and column family. So let's go for these NoSQL data models one after the other. Now, what is a data model? Data model is a set of constructs representing the information. In relational model, it is set of tables, columns, and rows. In a storage models, it is how database stores and manipulates the data internally. So a data model is usually independent of storage model. So storage model, data models for NoSQL systems are key value, document, then column family, graph based models. A flexible data model looks something like this. This is an example of a column family database system, right? Where you have key and value. So the key is like a primary key in your relational database system. The name of the table, in this particular case, it's a column family which is called as rockets. The value is something like this, right? These are all values which are depicted. This is a typical example of a column family database system. So key value stores is already stored on the disk. It is cached, right? There are two important things which are with respect to key value step. One is called as eventual consistent. A weak definition of it is if there are no updates that occur for a period, eventually all updates will be propagated through system and replicas will be consistent. A strong definition of consistency is that for every given update and a given replica eventually is either for an update reaches the replica or replica retires. So ordered is a distributed hash table allows lexicographical processing, right? Most of the NoSQL databases, whatever that we deal with, are basically eventually consistent. They are not immediate consistent with respect to the consistency factor. So some of the examples of key value pair: Azure App Fabric Cache, Memcached, VMware vFabric Gemfire. These are some of the examples of key value databases. So NoSQL data storage classifications are done in this way: uninterrupted key value, which is also called as big hash table. An example of this is the Amazon S3 Dynamo. Flexible schema is big data, big table, Cassandra, HBase, Sharpa PNUTS, which is used for JSON objects, MongoDB, which is a JSON object again, Couchdb, which is a name value pair. So when you take PNUTS as the data storage architecture, the architecture is something like this. You have routers. The request comes from the client from various places. The router handles the request. There is a master copy partition table mapping which is called as tablet controller. Now all the routers are mapped into different tablet servers. Now this tablet servers will hold some partition of the tables here, right? So whatever you see here are the partitions of the tables here, right? And whenever an access comes, the access comes to the router is aware of which table is available in which tablet server. Now, the very important aspect is the CAP theorem. This is a very important slide. The three properties of a NoSQL or a distributed database system is that it is consistency, that is all copies have the same value. Availability, system can run even if the part has failed. Via replication. Partitions, the network can break down into two or more parts with active systems that cannot talk to each other. So the Brewer's CAP theorem is said that you can at least have at most two of these properties satisfied, right? Any database, for that matter of fact, cannot satisfy all the three properties of the CAP theorem. It is because of the constraint that any one of the constraints may not be satisfied. So very large systems will be partitioned at the same time, where you can choose any one of them, right? In a distributed database system, you can either choose consistency or you can either choose availability. You cannot have both of them being implemented in a distributed database system. Traditional database system chooses consistency and availability. Most of the web application chooses only web availability as a very important part. Okay. Now look at some of the examples here. Consistent and available, but no partitioning here. The app is there. You have two databases, database A and database B here. So once when the data is stored in A, the data is also stored in B, right? Availability and partition, but not consistency. Data is stored in A. There is no replica that is connected with B, so it is not consistent. The old data is populated back to the app. So the next example is consistency and partition, but not available. A new data is being addressed to the database A. There is no consistency maintained. The data is gone there. So what was developed by the series of developers for distributed databases is that a base property was enforced, which is opposite of ACID properties for relational database. Now what base basically stands is basically available, soft state, eventually consistent systems. Basically available is all distributed systems cannot go down, the entire system cannot be affected, so they are basically available. Soft state, they are scalable as and when this data is being changed. Eventually consistent, given enough number of time, the data gets consistent across distributed systems. So this is a clash of cultures. The relational database system strictly abides by ACID properties. The NoSQL or the distributed database system strictly abides by base properties. So in relational database systems, you have got strong consistency, less availability, pessimistic concurrency, complex. In base properties, you have availability, willing to sacrifice any one of them, weaker consistency, best effort, simple and fast, optimistic concurrency. So when you talk about a distributed transactions, the distributed transaction happens in two-phase aspects. So the possible failures which can happen in a distributed transactions are network errors, node errors, and database errors. Okay, so the coordinator here has three databases, right? The likely failure can be at the coordinator level, where he can commit the data. The committed data should also be committed in all the three databases. So this is a one round of complete operation. And then he has to release the lock and give the acknowledgement. And if at all there is any issues with the transaction, there should also be a provision for the coordinator to do a rollback. So the problem in the locking cluster is that one node is down, possibly the implementation timeout, possibly there is no quorum, right? The use of quorum is very important to do committing by where the nodes will vote for the commit or rollback operations. So this is called consistent hashing, solving partition problems. Here the consistency is that consistency hashing is used for memcache, where servers S1, S2, S3, and S4 are there, right? You have a hash probability here, hash of data per mod server length. So the server length is 5 in this case, right? So the continuum approach is that you use virtual nodes in cycle, hash both objects and caches, easy replication, eventual consistency. If a node fails, there is a probability that you can recover it back. You can also add new nodes into this particular system. So the consistency model which is used in case of the distributed database system is that it is an optimistic concurrency versus a pessimistic concurrency in case of RDBMS, right? So here you can see here the root of operation, whenever there is an update which is happening, the update populates to all the places where it is supposed to populate. So this is an atomic pointer, right? So the atomic pointer is wherever an indexing changes, the appropriate data should also change. So the reads are never blocked, however, the writes are blocked, right? So you can see that the things which are marked in yellow is an obsolete version of the data. The things which are marked in green here or the new version of the data, right? So in an optimistic concurrency, it ensures that the data flows in the proper manner and the data is also updated. So then you have got something called as vector clock. This is used for conflict of used for detecting the conflicts in data gathering or data accessing. So stamp based resolutions will be used for this. So let's say that time t1 a database A has an item here. In time t2 this item gets replicated. Time 3 the replicated item gets updated. Time 4 there is an update which has happened to the original item, right? Now time 5 the original item which is being updated is started to be replicated, but there is a conflict in the detection because here also there is an update, here also there is an update. So you do not know which of these updates have to reflect in the replicated version. So availability as per the definition is 5 nines, that is 99.999% it should be available. So any large database systems or large distributed systems, the first of the expectancy is that the database should be available. There should not be any disruptions in the availability factor. So the network can be a big major culprit here because there can be disruptions of network every now and then. There may be issues of disruptions every now and then. There may be possibility that the system is resilient to face network disruptions. So there are certain strategies that you basically develop to ensure the availability factor is incorporated. Eventually consistent systems, there are no updates for a longer period of time, then only then eventual consistency will kick in. For a given accepted updates, the system will wait for a particular period of time and then it ensures that there is eventually consistent copies which are released at all places. Okay. Known as base theorem, basically available, soft state, eventually consistent. The soft state is the copies of the data items are consistent, eventually consistent. The common advantage of NoSQL system is that it is cheap, easy to implement. The data are replicated to multiple nodes, can be fault tolerant, the data is written in the latest version. There is no single point of failure, easy to distribute the data, does not require any schema. This is a very, very important factor, right? You do not need a fixed size schema or a visualization of the schema to enter the data in this case. That is the most important advantage of a NoSQL system. Now, what does NoSQL does not provide? It does not provide a join operation. It does not provide group by. It does not provide ACID transactions. It does not provide SQL. Integration with application is based on the SQL related systems, right? It is very quite obvious and meaningful because there is no partition. Because there is a partition in case of NoSQL. These are some of the things which does not work on a partition systems. Should I use NoSQL database every time? Yeah. The sense here is whenever your database or the data that you are trying to deal with is a semi-structured data or an unstructured data, it's important that you make use of a NoSQL storage system. Most of us work on organizational data, which is either log analysis, social network feeds and things like that. But if you are not coming across any such kind of data and your data is largely over low updates and your relational database itself will be a correct solution for that. So the next type of document store or the NoSQL system is the Apache, is the document store. The examples of it is the Couchdb, MongoDB, SimpleDB, XML databases, Apache Jackrabbit. Now, what is a document? A document can be anything like a web page. It has lot of empty spaces, lot of empty columns, wasted spaces. The document model stores the page as a space and it is very flexible. The second storage is the graph storage. The graph storage is also one of the type of NoSQL database systems where you have some of the example softwares are Allegro Graph, Core Data, Neo4j, Dex, FlockDB, Microsoft Trinity. These are all the NoSQL systems which helps you to store a graph basically, which is in terms of edges and vertices. So this is completely based on graph theory, scales vertically, there is no clustering. You can use any kind of graph algorithms. What are the graph algorithms that you have? Prim's algorithms, Kruskal's algorithm, Ford-Cousins algorithm, the traveling salesman problem. These are all graph related algorithms which you can basically use. So Neo4j is one of the very, very trivially popular graph database system where the nodes and relationships are used. Traversal are there. That is, it may be a breadth first search or a depth first search traversal. HTTP REST APIs are there. ACID properties are there in this. It has got a web admin. Not support too much of languages. It only supports C, C++. It has transactions. So when you take what's a graph is basically a node and edges. Nodes are called stations of the graphs. Edges are lines between them. FlockDB is one of the DB which is used as a very important database for Twitter. Nodes are users here. Edges are natures of relationship between these nodes. So what is the official database that is used by Twitter? It is called as FlockDB. It's a graph NoSQL database system. So next you have got object databases, DB4O, Gemstone, Intersystem Cache, Objective, ZodDB. These are all the object database systems. Couchdb is one of such examples of that. It's an AP tolerant database. Views are used for querying. It's an MVCC architecture, multiple concurrent version architecture. Very simple, REST API, schema free, nothing, shared nothing, seamless sphere, bidirectional replica, auto compaction, uses B-tree as its data structure, very important. Documents and indexes are kept in memory and flushed to the disk periodically. Documents have states in case of failures and can recover and continue from the database states where it is being left. No built-in auto sharding. You can define your own indexes for this. So the next one is objectivity of object-based systems. Okay, so you have complex data modeling in object-oriented database systems where you have collections like list, set, and map. Objective relations, bidirectional relations, ACID properties are enforced in this. Now we come to a very important type which is called as tabular data type. So Tabular is basically a columnar family database, right? Some of the examples are Google's Bigtable, Mesa, HBase of Hadoop, Hypertable, Azure's Table Storage, SQL Server 2012. So this is a row-oriented system, very commonly seen in RDBMS kind of systems. This is a column-oriented database systems, right? Where you see columns are being split into multiple cases and then you are storing the data. So there is no link between one column to another column, one column to another column as what we see in case of a referential integrity constraint in RDBMS. Cassandra is again yet another example of a NoSQL system where it has got tunable consistency, decentralized, writes faster than reads, no single point of failure, incremental scalability, consistent hashing, hinted handoffs, peer-to-peer routing, thrift APIs, multi-data center support, multi-synchronization support. These are all some of the salient features of Cassandra database. Cassandra is very popularly used in Netflix. Netflix makes use of Cassandra for a very long time. The replication factor in Cassandra in Netflix is 3. For more details on technology related aspects of Netflix, you can refer to this particular link. So the big data approach, you have MapReduce pattern framework.